Example 11. Find the derivative of y equals 6 to the x times log base 6 of x. Well, I clearly have two functions this time, 6 to the x and log base 6 of x, and they're being multiplied, so this is a product rule. So if y is a first function times a second function, the derivative of y is first times the derivative of the second, second times the derivative of the first. So my first function is 6 to the x, and my second function is log base 6 of x. Well, we need a new rule because we haven't taken the derivative of a constant base to a variable power. So here's what our new rule says. If f of x is a to the x, where a is a number, okay, then f prime of x is a to the x times the natural log of a. So if our first one is y equals 6 to the x, then our y prime is 6 to the x times the natural log of 6. And we know how to take the derivative of this second function. If y is log base 6 of x, then y prime is 1 over x times the natural log of 6. So we're going to put this together as our dy dx is our first, 6 to the x, times the derivative of the second, 1 over x, natural log of 6, plus our second, log base 6 of x, times the derivative of the first, which is 6 to the x, natural log of 6. So I'm going to do a little cleanup here. It's going to be 6 to the x over x to the natural log of 6 plus 6 to the x, natural log of 6, log base 6 of x. And this is a good answer, okay? Probably not necessary to refine it anymore. I do see that I have a 6 to the x in common, which I could factor out, leaving a 1 over x natural log of 6 plus the natural log of 6 times the log base 6 of x. And my x here almost makes it look like it's the log of 6x, but be sure that you're clear. That's log base 6 of x. And then I'll close my parentheses there. Either of those answers is fine. Now, you can't factor out this log of 6 because one's in the denominator, one's in the numerator, okay? So you can't bring it and just put it in the numerator since they're in different places. Example 12. Now this is related to something we've already done. Find the derivative of the function by first rewriting the function using the rules of logarithms. And so I already gave you a preview of this, and that is that you write a logarithm of a square root with a 1/2 power, and because it's a logarithm, you may multiply that power times that logarithm. And then when you do the derivative of y with respect to x, it's just the constant 1/2 times 1 over the internal function of the log times the derivative of that, which is 1. So it's 1 over 2 times x plus 9. And for this first answer, they want 1/2 natural log of x plus 9. They want you to acknowledge, you know, that a power of a log can come down as a product. Number 13, Suppose the demand function for x thousand of a certain item is P equals 110 plus 90 over the natural log of x, where x has to be bigger than 1 and P is in dollars. Find the marginal revenue. Well, marginal revenue is the derivative of the revenue. But we don't have the revenue, we have the price. Okay? Now revenue, that's the amount of money you bring in, is price times quantity. It's the price you charge times the number you sell. So our revenue here has to be 110 plus 90 over the natural log of x times x. And to make it easier to differentiate, I'll go ahead and write 110x plus 90x over the natural log of x. Now I can find my marginal revenue, which is my derivative of my revenue. Well, the derivative of 110, x is 110, and then this is a quotient rule. So my numerator is 90x, my numerator's derivative is 90, my denominator is the natural log of x, and my denominator's derivative is 1 over x. So the derivative of all of this is going to be, denominator, natural log of x, times the derivative of the numerator, which is 90, minus the numerator, 90x, times the derivative of the denominator, 1 over x, over the denominator, natural log of x, all squared. A little bit of reducing I can do is divide those x's out, and here I'm going to put my 90 in the front of the natural log of x, minus 90, and all of this is over the natural log of x quantity squared. So that's my marginal revenue. Now the revenue from the next 1,000 items when x is 4. Now notice this is x thousands of an item. So when x is 4, we just do r prime of 4. So that's 110 plus 90 times the natural log of 4 minus 90 over the natural log of 4 quantity squared. And they've asked me to find this rounded to 2 decimal places. So I'll use my calculator. And the safest thing, most likely, for you to do is to get a value for the numerator, a value for the denominator, go several places so you don't have a rounding error, and then round at the end. So in the numerator there, I have a 90 natural log of 4, close parentheses, minus 90. So this is 34.76649. I'll go 5 places. And then in parentheses, that natural log of 4 squared, 1.92181. And so that's 110 plus 34.76649 divided by 1.92181 is 18.0905. So add 110 to that, and we have 128.0905. So that's going to be $128.09 when rounded to 2 places. So the revenue from the next 1,000 items when X is 4 is 128.09, because that's how the revenue is changing for the first 4,000 items.